Good morning and welcome. We are excited to have you here today. It was at this conference last year, I just wrapped up the sprayer presentation, and one of our local agronomists I know quite well came up to me and he said, "Aaron, you know, I think there's something on the sprayer that's costing guys more than they realize." Now, that really perked my interest, one, because I'm a cheapskate, and I don't like things costing me more than I realize. And number two is I'm a research agronomist, and so I'm always looking for those problems that exist on a farm and how we can solve them and how we can understand them better. And so what this agronomist was talking about as he started to explain was the sprayer section control that Luke started with this morning, how that sprayers overlap when they come into headlands. And we've known this for a while, and we've always attributed this to lost and wasted chemical. But that wasn't actually his concern. His concern was different. His concern was what happens when we spray the crop with twice as much chemical. And that actually intrigued me. And his theory was, is it possible that sprayer section control is actually costing farmers more in the yield loss in these areas than it is actually the chemicals they're wasting? And so I told them right then and there, I'm going to test that in 2024, and we're going to take a look at that. And so I put some sprayer trials out, and you can see in this picture on the left, I have where we overlap with the sprayer, which is a 2x rate. And you can see those soybeans struggling in health as they try to metabolize that extra chemical. And then on the right, we have the normal rate. So we followed this all the way to yield, and we took a 1 bushel hit in those areas where we overlap, costing us $10 to the acre. We also put a corn plot out. And as you can see here, where we had a normal blanket rate, it yielded 275 bushel. Where we overlap, though, it yielded 259. We took a 16 bushel to the acre punch on the chin, $64 the acre loss. And so in this case, it was actually more than we were spending on chemical. And so we'll continue to research this because I think there's going to be a wide variety in how much this costs growers depending on the crop and the chemical that we're using. But I think it's good to realize that sprayer section control not only costs us in wasted chemical every year, but it's actually also costing us yield. And like I said, I'm a cheap guy, and so to have something in my operation that's costing me year after year just really bugs me. And it especially bugs me when I don't get any value from it. I think of it like federal taxes. You pay them every year and you don't get anything in return. And so I would much rather have a technology to solve this issue, such as SymphonyNozzle, where we have individual nozzle control and we don't have this nickel and diming us. Now the wasted chemical, this goes for everything that goes through the sprayer. Everything from fungicide, insecticide, even fertilizer. But for the rest of the presentation, we're going to dial in specifically on weed control and herbicide programs. And so when we take the sprayer to the field, and our goal is to control weeds, how do we know if we are successful? Well, it's pretty simple. This is our goal. Our goal is a clean field. And if our fields end up like this, we didn't achieve it. Why is this not success? Why do weed escapes hurt you? Or why do weed escapes bug you? Well, in your head, think of the top 5 reasons that you don't like a weed escape. And I'm going to try to guess on 3 of them. One of them is because you just flat out don't like looking at weeds. And another one could be the fact that you don't like your neighbors looking at your weeds, and you don't like your landlords looking at your weeds. And then also top on the list would be the fact that these mature weeds, they have seed. And we know if we let a weed escape like this go to seed, that it's going to cost us in the years after that. And so just how much seed is there when we have a weed escape? And so I dug pretty deep in the research of our most prolific weed in the US right now, Waterhemp, to try to get a good idea of how many seeds do these plants produce. And what I came up with is there's about 28,000 to 160,000 viable seeds produced by a single female plant. And so we're going to take a nice round number in the middle. We're going to say average 100,000 seeds per female plant. Now, water hemp's actually a little unique. It has separate female and male plants. And so actually some of these water hemp in your field actually don't have seed. And so if we average those out with the male plants, it's going to be about 50,000 weed seeds as you just look across your field on average per plant you're seeing. Now, what happens to those seeds? Well, 25% of them will germinate the next year. And then also, there's a 40% annual mortality rate. So in 1 year's time, 40% of them will become unviable or die, so to speak. And so you can see as a water hemp, it produces a lot of seed, but actually has a fairly high mortality rate. There's other weeds like velvet leaf that are the opposite. They don't produce as many seeds, but they last a really, really long time in the soil. And you can pick your poison, but neither one of them is real good to work with. And so if we have a water hemp escape, let's say last year we had an escape of 1 water hemp for every 50 foot by 50 foot. So if you think about that, that's just a water hemp here and there, nothing major. But that comes out to be 17 water hemp per acre. You multiply it by 50,000 viable seeds, and you get 850,000 seeds per acre. Now, 17 water hemp don't sound that bad, but 850,000 seeds per acre, that doesn't sound real good. And these are viable ones that can germinate. And in year 2, we're going to have 25% of them germinate, and we're going to have 99.98% weed control. That sound pretty good? We're going to only let 1 in 5,000 of those germinating weeds survive. So if you run the math, we have 850,000 seeds times 25% germination, which is 212,000 germinating weeds. We divide it by our weed control, we end up with 42 water hemp. That's 2.5 times our initial escape. But that's not it. Now we have all the seed from the water hemp, and that's 2.1 million seeds. Plus the seed from the year before, subtracting off the 40% mortality and the 25% germination, we still have 300,000 viable seeds ready to germinate. You add them together, you get 2.4 million seeds per acre. And so let me shrink that up for you. Well, if you're like me, anytime you go backwards in weed control, you're thinking, I need to do a better job. And so in year 3, we're going to step it up. We're going to have 99.99% weed control, only letting 1 in 10,000 survive. So we're controlling twice as many weeds for every one that we let by us. If you run the numbers here, though, you still end up with 60 water hemp per acre. You still had a 50% increase from the year before, even with better weed control. Have you ever had this happen to you? Where you thought you did a better job, you thought you killed more weeds, and then at the end of the year, you felt like you actually went backwards? Well, that just shows you the power of the soil seed bank. It's a real threat to our weed control. 60 water hemp come out to be 3 million seeds per acre, but then we have leftover seed from years 1 and 2 now, subtracting off mortality and germination, and that's 840,000 seeds per acre. You roll those together, you get 3.8 million seeds per acre. Now, we could continue down this road for a long time with subpar weed control, and our population would continue to explode. The math would continue to explode. And so I want to run one more scenario, and I'm going to say in year 4, we have 100% weed control. Now, that's truly a feat, because if you run the numbers, you would have almost 1 million seeds per acre germinating. And you're going to end up with 0 water hemp. So that might be adding extra residual. That might be making a whole extra pass. That could be hiring your sons or your neighbors to go walk your fields. But you end up with 0 water hemp. Congratulations, you won the battle. But the problem is you didn't win the war. Because if we take the seeds from years 1, 2, and 3, subtracting off mortality and germination, we still have 1.3 million seeds per acre. That is more seeds per acre than your initial escape. And so what can we learn from this? First one is 99.99% weed control is not enough. As you can see, if we have subpar weed control, it continues to expound and make your job harder. Also, another reason why 99.99% weed control is not good enough is it's because it's the easiest and the cheapest to control the weeds now. And I know that's easy to say, but the 17 Waterhemp per acre were easier to control than on year 4, where we had to control 1 million germinating seeds per acre. And the last one, as we saw in year 4, is weed control is a multi-year war. We've got to get into a long mindset. It's not a one-year battle. It's actually one of the reasons why I believe the sprayer pass is one of the most important on a farm. If you mess up the planter, it's going to cost you dearly that year. Planter is a highly agronomic pass, and there's some serious implications to your bottom line when we mess it up. But it's only for 1 year. If we mess up on the sprayer and we mess up with our weed control 1 year, that's going to cost us for multiple years. And so I'm going to have Scott come up. He's a product specialist on sprayers, and he's going to show us a few things we can do on the sprayer to make it better and to make it not the reason for a weed escape. Go ahead, take it away, Scott.
Thanks, Aaron. Good morning, everybody. Happy you're here because I'm excited to share some different ways with you on how you can optimize your sprayer's performance, as Aaron said, so that it's not the reason for those weed escapes. Right? Getting that operating at its peak performance is critical because of the number of passes that it makes in a season, right? So when you think about that sprayer, what are the things that it needs to do and do well as you're going through the field? It needs to control the rate that you want, right? Whatever you enter into that monitor, it needs to be hitting that and you're confident in that. But it also needs to be applying the correct coverage for that product you're applying. So that's the two main things when I think about a sprayer. Now, as an operator or an owner, there's one component on that sprayer that you have, direct input into as you're getting ready for the season, and plays a big part on those two performance metrics of a sprayer. And that's your nozzles, right? Sometimes that can be a challenge. How do you know if you have the right one? Do I keep using the same ones I've used for 5, 10 plus years? They've worked well, I've gotten along pretty good with those. Or do you need to review those and change those so often? Who's looked through a nozzle catalog recently? Anybody out there? A few of you? How'd you feel afterwards? It's a little overwhelming, right? There's tens of hundreds of different options out there. You could have a standard single fan nozzle, twin fan, air induction. There's no shortage of different options. So coming back to that question, how do you know what's right? Are you using the right one? Well, you have to start with that product label, right? Review your chemical program, see what you're applying, and then match those nozzles up to that. They're going to give you a direction on how you need to apply that product. Now, in true precision planting fashion, we could review those charts all day long, match things up, but we want to see for ourselves the performance of those nozzles. We want to see how they're actually working, right? So who wants to see some live demos today? You can do some live spraying in January. That'd be pretty cool, right? So we're going to do that. We're going to actually use this 2-nozzle sprayer stand behind us here. We've got our Gen 3 2020 hooked up to it, controlling it. But we're going to be able to test some different nozzles in different conditions. And we've got some water-sensitive spray cards laid out in our track. So as we spray, we'll grab those and we'll kind of review it. So we saw that first run there. We were actually using that time a T-Jet TTI nozzle. So you could see it was a twin fan style. And we were running 10 miles an hour, 13 gallons an acre at 48 psi. So we got that from our nozzle charts. So as we look at the spray cards, when I analyze those, there's really two things that I'm looking for. The first thing is going to be those large droplets, and we can see some of those here. The second thing I'm looking for is, are there half-inch square areas where we're not getting product coverage? And we could have those weed escapes like Aaron talked about. And we see some of those with this particular nozzle at those conditions, right? we've got some areas where we could have a small weed escaping. And as we go back to those large nozzles, or the large droplets, what happens with those? Now on the spray card, they didn't look too bad, right? They hit, you could see a little bit of splatter, but out in the field, when you've got more of a vertical leaf, those larger droplets have a higher velocity, they hit that plant leaf, they rebound, they explode like you see in that video, and then they don't stay on that target, right? So with those large droplets, you're kind of balancing that drift control versus maybe some drop in coverage. So we can see that on that card. Okay? So maybe that nozzle's not quite right for what we're looking for. So we've got another one switched out here, and you can instantly see the droplet sizes coming out of this one are quite a bit smaller, right? We can see that spray plume starting to build there. And you could especially see that, that drift tail, if you will, as that ran down our track. So we were running at the same conditions there. Now that was another T-jet nozzle, one that's been around for a number of years, pretty widely used. That was an extended range or XR nozzle. So as we take a look at that one now and compare it back to our first one, again looking for those two items I just mentioned, the large droplets and/or open areas, what do we see here? This spray volume with that particular nozzle, we don't see really any of those large droplets, right? So our spray volume, we're getting more droplets, but they're smaller. So we're getting good coverage here. We're not having those weed escape areas. But in this controlled environment, that spray plume, as those droplets got up into the air, they were able to just fall right back down onto that card. If you think about out in the field, what's going to happen? You're going to have those environmental factors, temperature, humidity, wind, the turbulence from that spray boom as you're going through the field, and those droplets that get up into that spray plume, those really small ones, one of two things are going to happen. Either they're going to evaporate before they get down to that weed, so they're not going to do you any good, or second, they're going to drift off target, either onto a neighbor's field, the landlord's tomato patch, where they could do some real damage, and that's not what we want to see. So again, maybe that nozzle's not quite right for our application. Let's try a third one here and see what we can get. And this will also, again, be at that 10 miles an hour, 13 gallons an acre, 48 PSI. That was another T-jet nozzle, another twin fan option. That time it was an AI-TTJ. So as Ben's getting our card situated here, we'll review it and compare that back to those other two. Now this one, we do see some larger droplets on there, not quite as large as that first nozzle that we ran, right? But you'll notice we also are getting a few more small droplets compared to that one, and we're getting better coverage as well. We don't have those areas really where we're not getting product applied there. So that one looks better compared to the other two, right? But what's your sprayer monitor going to be telling you? Those were all at the same rate, correct? So if you're going through the field, it'd be telling you you're hitting rate, you're doing a good job, but that's not the only thing, right? You have to think about that coverage. And we can see these three are drastically different, even though they're the same size nozzle, they're just different types, okay? So you have to think about that coverage piece. Now, when you're selecting nozzles, a lot of times they'll use either droplet size or a term called spray quality. So how does that compare to those coverage? Well, that's an industry standard. Most manufacturers are using either an ASABE or ISO. They're very similar, but they're categorizing those nozzles based on the median diameter of droplet size that it produces. But you can see it's a range. Just because a nozzle might fall in a coarse category there doesn't mean it's only producing one size of droplet, right? There's going to be small ones, there's going to be larger ones. It's categorized on that median diameter, what's in the middle. But you're going to have 50% of that volume made up with larger droplets, 50% made up of smaller. So you have to find that balance. Now, as we compare these three that we just ran, that XR nozzle had those much smaller droplets. It's going to be on that more fine end of the spectrum. But as you get into those categories, like we see, you're going to have more of those smaller droplets. So theoretically, you'd be increasing your coverage, but you have that higher risk of drift, or those droplets not making it to that target. Okay? Now, if we look at the other two nozzles, they're more on that larger end of the spectrum, or in those coarse categories. And what you see there is you get those larger droplets. Your volume is tied up in those. You have lower drift potential, right? But you're risking some of that coverage. You might have some spots where you're not getting product out in the field. So you kind of have to find that balance on what you're looking for, right? And again, back to that question, how do I know which nozzle is right? Which one should I be using? Well, you have to go back to that product label, right? It's going to give you an indication or a requirement on what that droplet size or spray quality needs to be. Then you can match your nozzle up to that, okay? So if we look at 2,4-D label here just very quickly, it states, if that's the sole chemical in your tank mix there, it needs to be applied at a coarse or coarser spray. So we had two nozzles that would meet this label requirement, right? So how do you choose? Well, again, that's back to your preference, maybe some of the conditions you're going to be operating in. Do you want better drift control, or are you looking for more usable droplets and better coverage? So you have to kind of find that balance. But for today, we're going to stay with that AI TTJ, that last one that we ran. We liked how that one performed or looked there, so we're going to stay with it. We got it outfitted. We're ready to go to the field. We start operating. How does that traditional sprayer, as you're going through the field, what does it control to? What's it trying to maintain and keep consistent? It's your rate, right? Whatever you enter into that display, it's trying to keep that as you go through the field. But what happens when you speed up or you slow down? The flow through that sprayer changes, right? As you speed up, that flow has to increase so you can keep that consistent per area rate, and then your pressure increases. If you slow down, that flow decreases, your pressure decreases. So how does that affect your spray quality? Well, let's test it out. We get up to, let's go 12 miles an hour.
Man, Scott, I don't know if this stand's made to do this.
You don't think we can handle it?
You think we should still send it?
Yeah, I told him we'd test it. Let's go. Okay, so again, that was at 12 miles an hour and still 13 gallons an acre. So if we go into our tip chart, that would be up to 70 psi. So a relatively small speed change led to a 22 psi difference. So how did that change the spray quality? Well, as we compare that now to our 10 mile an hour card, it looks fairly similar, but as you study it, you can start to see that spray volume is made up of more of those small droplets, right? As we increased that pressure, that changed the spray quality from that very coarse now down to coarse. Okay, we don't see as many of those large droplets. We see more small ones here, so we're getting a little better coverage, but out in the field, that could lead to some of that drifting off target on those smaller droplets, okay? So let's go down to the other end, about 8 miles an hour. As you're coming out of corners, maybe slowing down for some washouts in the field there. Let's see what that looks like. And then this time, dropping that speed, our pressure dropped down to 30 psi. So again, small change in speed led to a pretty big decrease in pressure there. And it's a little bit more evident now, right? As we've got that lower pressure, now we're seeing some more of those large droplets show up across here, and that spray quality, again, has changed. It went from very coarse now to extremely coarse. So you can see the challenges with that traditional sprayer. Even the most careful operators, the most cautious operators, they're going to be faced with this, right? That's not anything that you can really do to change that on those traditional rate control systems. Even if you have the right nozzle selected for your normal operating conditions, that's a challenge. So what can you do? Right? Well, a system like SymphonyNozzle, which is that PWM nozzle control, gives you independent control of rate and pressure. So not only now can you control that rate, but you can keep your pressure consistent across those speed changes, giving you a wider operating range there and keeping that spray quality that you're looking for. So we're going to take a look at that and how it performs. Aaron's got some things switched around, and you can see now those nozzles pulsing, right? That PWM style operation. So we're going to run it here at that 8 miles an hour, but now keeping our pressure at that 48 psi that we were looking for initially. Okay? And we'll compare that back to our standard sprayer. And as that starts to dry here, we can see that difference, right? We don't see as many of those large droplets on the Symphony system like we did with that traditional style spraying there, that rate controller system. And we're getting some better coverage as well. We're keep maintaining that pressure, keeping that spray quality where we want it. We don't see those areas where we've got open spots and not getting that product applied, right? So that's how a system like SymphonyNozzle can solve those challenges, keep your spray quality, your coverage accurate and consistent as you're adjusting speeds going through the field there. Okay. Now, one thing that we have noticed over the years with those PWM systems is when you're selecting nozzles, you need to size those 30 to 50% larger than on a standard sprayer, assuming you had the right size to begin with. And what that does is really provides that system that wider flexibility or that wider operating range to be able to push it up to 12, 13 miles an hour. Or when you need to slow down for those rough spots or coming out of corners, some of those harder to control areas in the field, it's going to maintain that consistent spray quality through those changes. Okay? So we've got another nozzle on here now. So thinking about those PWM systems, we've switched it out to a larger nozzle. So we've went up to a size 10, and it's actually a 𝗧𝗶𝗺𝗀𝘀, so it's a full drift reduction style nozzle. But we're going to run that and see what it looks like here.
Give me a minute, maybe let's look at the previous one.
So we had backups just in case this would happen. It's always a risk with live demos, right, that something doesn't quite go as planned. But oh, now it's back up. It's just like true operating conditions too, right? Nothing ever goes 100% right in the field. Okay, so as I mentioned, this was a size 10 𝗧𝗶𝗺𝗀𝘀 nozzle. And what I would expect with it being a full drift reduction and a larger nozzle, we see that spray volume is tied up in a lot of those large droplets, right? That's what it's supposed to be doing. You're not going to have that risk of small droplets drifting off target. But we start to see those areas there where we're not getting coverage and we might be missing some weeds out in the field. So that's one of the drawbacks of those larger nozzles like that. You're making a choice on if you want that drift control at the lack of some coverage. Okay? So our team, again, kind of dug in and said, well, why do we have to make that choice? Is there something that we could do to improve that? So we started reviewing some of the Wilger charts here, and they're great because they give you a little bit more information on that nozzle and how it's going to perform as far as the distribution of droplets that it produces. And there's two columns I want to look at here. So the first one I've got highlighted, that's droplet sizes of less than 141 microns, which are considered driftable fines. So that makes up 5% of that spray volume coming out of this nozzle. Again, that's what it's intended for. But if we look at this next column, anything less than 600 microns, those droplets are considered a usable droplet. It's going to hit the plant, stay on it, it's going to give you that coverage. Well, that's only 54%. So there's room for improvement there, right? So as the team kept digging in, they looked through some more charts, and what they found was if you stay in that same series, so still a DR nozzle, but you go down to a 0.5 size, you can actually reduce your driftable fines and increase your usable droplets. And it was by a pretty big amount. You can see, comparing those two columns, you can reduce those driftable fines by 40% and increase your usable droplets by 35%. So not only get better drift control with a drift control nozzle, but also get more usable droplets and better coverage. So that's pretty big, right? You no longer have to make that choice necessarily. So the team, again, got those gears turning. How can we get that performance out of that smaller nozzle but keep our same rate that we need that that larger nozzle for? Well, I want to introduce today a new component, new tool from Precision Planting called NozzleSplitter. And it's a simple tool you can see here, but for those PWM systems or even traditional sprayers, if you're running higher speeds, higher carrier volumes, where you're using that large nozzle, anything 0.8 or larger in a single fan with those large droplets, that allows you to split that large nozzle down into two smaller nozzles, keep the same flow you're looking for, and get that better performance like we just showed. But again, let's not just take the chart's words for it. So let's run it and see how it compares. Okay. So we've been running these Wilger nozzles at 12 miles an hour, 15 gallons an acre, and 60 psi. So a little different parameters, right, with that larger size. But as we look at it, it's pretty easy to see the difference, right? I mean, the visuals line up with those numbers from the nozzle or from the charts. So we can see we still have some larger droplets in there. Again, that's the style of nozzle that we're using, but our coverage is much better, right? We don't have those open areas now with the splitter where we could have those weeds escape. So those numbers line up with the actual results here. So that's huge. Now there's one other thing I want to call out on that. If we go back to the slides here, is you'll notice that it's got a straight down spray angle, right? So you're probably thinking, well, I've got twin fans or I've got some other nozzles that have a little bit more of a forward or backward spray or a different incline on them. And you know, those have their purpose out in the field. If you're trying to hit more of a vertical target and you need to spray both sides, those work well for that. But for herbicide applications where you've got 12, 15-inch tall crop and you're trying to get down to a weed that's 2 inches tall, that straight down spray is going to give that droplet the shortest distance to get down to that. It's going to be able to keep its velocity higher to punch through any canopy or get through leaves on the crop as well and get down to the weeds. So we believe in that herbicide application, straight down is the way to go there. So again, that's an easy tool to help improve that nozzle performance. But even if you get the nozzle selected, you match it up with your products, you try and maintain that consistent operating speed, that's still not enough. There's one more challenge of those traditional rate control sprayers that exists out there and is a big problem. And that's turn compensation, right? Some of you may have fields like this. Some of you may have more extreme curves than this. But as those traditional rate control sprayers are going around that curve, what happens? It's trying to control to that gallons per acre, right? But on that inner portion of the boom, as it slows down, those nozzles then start to put out more product per area. They're covering a smaller area as they come around. The outside wing, or the outside boom, as it comes around, it's covering a larger distance, putting out less product per area, right? So that's a real problem in those situations. So a few years ago, our team outfitted a product called EM Flow Sense onto a sprayer, and that measures liquid flow. And they put it on every nozzle. They wanted to see what is the difference across that boom. So as they took it out to the field, this is a screenshot of the 2020 and that flow map. And if we zoom in around that corner there, what they found was pretty staggering. They were going for 15 gallons an acre, and on the inner portion of that boom, that EM flow sense measured up to 30 gallons an acre, or 2x the rate that they were intending. And as Aaron showed earlier, not only is that wasted chemical, but it's also that 2x overlap, and now you have that yield reduction from that. Okay? How about the outer portion of the boom? That went down to 7 gallons an acre, or half the rate. And what happens in that situation? That's where you get those weed escapes, exactly. And that's pass after pass, year after year. You're putting on less chemical in those areas, and you're going to build that soil seed bank, as Aaron talked about. So again, that's a real challenge with those rate control systems, even if you get your nozzles selected correctly, that you're still going to battle there. Now, SymphonyNozzle, again, can solve that challenge with that nozzle by nozzle control, turn compensation capability. Those inner nozzles can apply less product, adjust their flow, and those outer nozzles can apply more to keep the rate consistent across the plant or the sprayer bar there, or boom. So that's some ways that hopefully you can take back with you to help optimize your sprayer performance, and how SymphonyNozzle can solve those challenges of a traditional rate control sprayer, laying the foundation for what's next in spraying technology. So Aaron's going to come back up now and talk through some tools on how you can select the correct rate and take that sprayer to the next level.
Thanks, Scott. It's pretty exciting to see how there's different technologies that we can use to make a sprayer better, and how you can see it live here in the results of the spray cards. But once we have a sprayer that's dialed in and we are about ready to go to the field, how do you guys decide what chemicals to use and at what rates to spray them? Most of us, we sit down in the winter and we like to plan out a chemical program. We like to plan out what we think we'll use that year on our farm. But before we go out to the field, we need to go scout. We need to make sure that the program we're planning on is going to do a good job in weed control in that field. And so what are we looking for? We're looking for things like weed species and how tough those weeds are to kill. We're looking for weed size, weed density, because we want to make sure that our program we're planning on is going to get everything that's there. And so sometimes we might have to run higher rates or add an extra chemistry to make sure we get the big weeds. Other times we go out to scout and the residuals held well. We don't have nearly as many weeds as we thought, and they're pretty small, and maybe we remove a chemistry or we run a lower rate. And so I want to take you on a scouting journey through one of our fields. And as we do this, I want you to think about your corn program, what you spray on corn, and think about the decisions you would make based on the pictures I'm going to show you. So this is our Terhune field. We use it for sprayer testing, planted in corn this last year, and I'm getting ready to spray the post-pass on this field. And so as I make this big loop and scout this 100-acre field, what I find is about 25% of the area that I scout are these small weeds. Waterhemp are small and they're really sparse. So I'm not too worried about being able to get those. And then I also find that most of the area, around 70% of the area I scouted, is just clean. The residuals held really well, and they really don't need any contact killer in that area. And then I also see down in the corner where our seed bank is a little more hefty, and we have butted up against the neighbors for multiple years now, you can see we have a lot more dense weeds. Still pretty small, but there's just a lot of them that I need to be able to control. And then I find one other spot in the field that looked like this, where we have more mid-sized water hemp, fairly dense around the base of the corn, and amongst this area, I find some of these, some 6-inch plus tall water hemp. And then in the back of my mind, I'm thinking, man, is the program I'm planning on actually going to be able to get these? And I'm also thinking the crop size, as you saw in some of those pictures, this is my last shot at it. And so I want you to think about your program, and nearly every chemical on the market gives you a range at which to apply it at for rate. And so what is the correct rate in this field? you have a couple options. You could spray it at the low label rate, the low end of that range. That would probably do pretty good for all of the small water hemp in all of the areas that don't have anything. Or you could spray at the high label rate and have a shot at getting those big weeds and those dense weeds. Now here's the problem, is at least for our program, to spray at the high label rate versus the low label rate was $12 the acre. Now I told you I'm a cheapskate. I mean, I'm like most of you guys who are still using their jeans and t-shirts for shop rags, okay? To save money, and now we got to spend $12 an acre for a 100-acre field. That's $1,200 just to control such a small percentage of the field. And this is actually very common in our post-passes. And so there has to be a better way, and the better way is actually to variable rate. And so if we are able to variable rate, well, now we can put the high rate on the big weeds, give it the full punch of our program. Those are the hardest to kill. We can put the low rate on the small weeds and the sparse weeds, easy to kill. And we can also put the high rate on the dense weeds because some of their leaves might be overlapping and there's just a lot of them there that we need to kill. And so we want the high rate on there. And what's really interesting, for the program we were spraying, we can do this for 30 cents the acre. Now this is something my cheap self can get behind. Now I'm $30 and I can actually punch in the big areas. And so that's why we're so excited about SymphonyVision and its ability to categorize weed size and density into one metric called weed severity. Luke talked about this morning, and as you can see on the map here, this is a map of that actual field. So you can see about 70% of it did not have any weeds. And then the yellow, the low weed severity, is all these areas with just a few small weeds. And then the red in the area, which you can see is not very much, we have the large weeds and the dense weeds. And so now as real time a sprayer goes through the field with SymphonyVision, we're categorizing and we're mapping how tough are these areas in the field to kill. And now we have a few product packages that are able to control your rate based on this metric. And those two packages we call SymphonyVision Rate and SymphonyVision Spot. They both have this variable rate capability, high to low. They also both give you full resolution weed maps for scouting and decisions. I've been blown away by how powerful these are. I've learned a lot about my weed management based on these maps. My favorite use, though, is the scouting portion. I like to follow up scout a couple days after I spray a field. And before I would go follow up scout, before I had a weed map, and I would just kind of wander around and make sure I got everything. And now with these weed maps, I pull up, I look at the highest weed severity, the areas that were toughest to kill, I walk straight there, I make sure I got them, and then I can leave. Because I know if I kill those areas, I've killed the whole field. Now another interesting thing as we variable rate high to low is we can actually keep residual into the tank. So residual also typically gives you a range at which to apply it at. And so not only can we variable rate the contacts, we'll variable rate the residual with it. We especially think this fits really well for post applications, where the next flush of water hemp is probably going to come where the current flush that you're spraying is. Now here's where they get different. SymphonyVision Spot has one extra capability that Luke talked about this morning, that spot spray capability, where we're actually shutting off nozzles. We're going to pull residual out of the tank, so obviously we're not spot spraying residuals. I've tried it just for fun and it just doesn't work. So we're spot spraying with the contacts. Now, as you can see here, we have on the boom 5-foot camera spacing here. This is actually on Luke's sprayer. You can see on this boom, it's a light architecture, easily goes on an existing sprayer. Now SymphonyVision Rate's actually a lighter architecture, 10-foot camera spacing, so it'd be roughly half the number of cameras and therefore roughly half the cost, and we still have the variable rate capability. And so let's take SymphonyVision Rate and go back to our field example. And now I want you to put yourself in my shoes. So my original program was dual magnum, Calypso, atrazine, and Roundup. And as I was looking at this, none of these products are rated to take down water hemp bigger than 6 inches. And so I'm not that big of a chemical expert, so I call my chemical guy and I say, hey, you know what? This is what I'm planning to spray. This is what I got out in the field. What do you think? You think you can get them? And you know, us agronomists, we always have helpful answers for you guys. Typically something like, it depends, or maybe. And in this case, it was, Aaron, you know you might kill them and you might not. And I thought, man, is that helpful? And so I'm like, what can we do to make sure I get them? I don't want to take a risk of a weed escape in dealing with the seed. So I asked him what we can do. He said, let's add a chemistry that works really good on big water hemp. And so we added Diflex into that tank mix. Now that's pretty cashy, but at the same time, I'm not going to blanket this tank mix. I'm going to variable rate it. And so if you come back to our map here where weed severity is none and low, we're going to run that low chemical rate. And that's low end of the label rate. That's going to cost us $42 the acre. And then as weed severity steps up to medium and high, we're going to step up our cost and our rate. And so at high weed severity, we're going to give it the full force of that tank mix. We spend $42.30 the acre, and we end up with a clean field. Now, you could have ended up with a clean field without SymphonyVision rate. But the problem is if we had to apply that tank mix, it would have cost us $56 the acre. So we had a $14 saving with SymphonyVision rate. Now, some of you might be thinking, you know, Aaron, you're cheap, but I'm cheaper than you. There's no way I would have added that Diflex. I would have took my risk and kept it out of the tank mix. Well, if we would have blanket applied without Diflex, that would have cost us $39 the acre. So it originally cost us $17 to add Diflex into the tank mix. But with SymphonyVision rate, we added that entire chemistry, variable rated, and it only cost us $3. And so I spent $3 the acre to make sure I got them. And that's what makes me excited about SymphonyVision rate, because no matter your field, if there's any variation in weed, it's either going to do one of two things. It's going to either increase your weed control for roughly the same cost, or it's going to keep your weed control the same and it's going to save you money. And so to recap, let's think of the ways that we've learned that we can prevent these weed escapes. Because we learned it's a long war on weeds, and we've got to pay attention every single year. And Scott laid out well that starting with the correct nozzle is a big deal. Just because your monitor says you have the correct rate doesn't mean every single weed is actually. And there's a wide range of nozzles out there, and their performance is vastly different. And so pay attention to your catalogs. Also, if you want spray cards, our premier dealers have spray cards. So you can order them and you can see what your nozzle looks like on the spray card in your conditions, on your sprayers with your nozzles. Also, for you guys that are running 08 size tips and larger, it's a no-brainer to just turn that knob and run 2 smaller tips, increasing usable droplets, reducing driftable fines with NozzleSplitter. It's just one more thing, simple device that we can do to make that sprayer better. But once we have a good spray quality and we have good sized droplets, we've got to maintain it. And if you think about it, if we're coming out of the corner with the sprayer, this is on a traditional sprayer, this is where we're having the lowest pressure, which also means that is the area of the field that has the worst coverage for the nozzle you're using. Always. The lowest pressure is always typically the worst coverage of that nozzle. And in an area where you need it most, in the corner, or if you've got weed pressure coming in from 2 field edges. And SymphonyNozzle can solve that. SymphonyNozzle also can solve these areas of half rate around turns. And I think about it, if we're in a mindset that we got to get every single weed in our field, it's really tough to do if you have field edges where you're putting on a half rate. And now those weeds are providing your soil seed bank for that field. Also, SymphonyVision rate is a great tool to prevent weed escapes, because now that we're categorizing weed size and density with the cameras, we can hit those areas of big and dense weeds. And we can also add additional modes of action cheaper. I always have to chuckle. The universities always say, you know, as you add chemistries, it would really help us with resistance. You know, run more chemistries, run more modes of action. And I always think to myself, yeah, but it adds cost to me every single time I do it. Well, now with SymphonyVision Rate, it's not adding near as much cost to run an additional chemistry. But as we're preventing weed escapes, that's tough to put a dollar amount. It's really tough to be able to actually put dollars to what a weed escape costs you. And so another thing I like about some of these technologies that go on the sprayer is we can actually pencil out some aspects of them and increase your bottom line. So you take, for example, SymphonyVision Rate, and it's going to prevent that wasted chemical on all the areas of the field where you don't need it. How much? Well, if we think about this field that we ran for the example, and we expand that out to 1,500 acres of corn, if we would have ran that same tank mix blanket across the acres, it would have cost that farm $21,000. And also SymphonyNozzle, by getting rid of this overlap, we can also save money and increase the bottom line. How much? Now this is a much tougher one because there's such a wide variety of fields and a wide variety of farms out there. But I'm going to use a $45 acre corn cost, a $65 acre soybean chemical cost, that's including fungicide in that, 3,000 acre farm, 4% overlap. We see a lot of that 3 to 5%. And if you run the numbers on that farm, for an example, that's $6,600 in wasted chemical, $4,400 in yield penalty. See, that's that extra cost that local agronomist was concerned about that we really didn't know was there and nickel and diming us. So you add these up, there's $32,000 of opportunity. And so I understand every farm's different, and so I encourage you to work with your precision planning premier dealers. They can help you run scenarios on your farm. They have tools like spray cards and calculators to see what these things will look like on your sprayer in your conditions. So I want to thank you for your time and attention. Scott and I will be up here for questions. You're welcome to come up, take a look at the spray cards that we just ran. Thank you.